Uh, um, all right.
We're not seeing
Thank you.
Kerry.
Oh, okay. So I think I might just start. Then, yeah. All right. Thank you everyone for joining us for this session. My name is Perry. I am based in the South African office at EIT offices in Johannesburg. And thank you for joining us for this session. But just before I introduce our presenters today, I just want us to go through some couple of guidelines in terms of notifications and sounds. So if you can just follow these instructions so you don't get any form of disturbance when you're watching this session. All right. Once again, welcome to Insights into EIT Advanced Diploma in Biomedical Engineering. This will be presented by Bruce Morrison and Dr. Kerry Newlin. These are our lecturers here at EIT. Just some common questions in terms of slides and the recording. We will be providing you with a copy of the slides and the recording. So just ensure that you look out to your emails in the next, I would say, 2 business days. We should send that to your email. So just check under junk or spam folder. But just a quick one, especially for those who are joining us for the first time, just to give you an overview about EIT. As you might know that EIT, we specialize and focuses on engineering. We deliver courses such as professional certificates, diplomas, advanced diplomas, undergraduate, graduate certificates. We have bachelor's, masters, and then our highest qualification at EIT is doctorate, Doctor of Engineering. And we are industry orientated, a question could be, what does that mean to a student? Is that once you've completed the qualification, you still have what is relevant in the industry. So our courses are industry aligned. Our academics are working very hard to ensure that all the resources for students and materials they use, they are always up to date to, to keep up with the trends and the changes in the technology itself. And we just like any higher education provider in Australia, we are accredited with Australian government, and we have some of our programs that are recognized under 3 international engineering accords. You get your advanced diploma under Dublin Accords, you get bachelor's under Sydney, you get a master's program under Washington, and we source our lectures from different parts of the globe. So we really want to give our students a global engineering perspective, and a lot of students get to interact with students from different parts of the globe. We make use of very unique methods, special methods in terms of delivering our programs. So we have live interactive webinars where you are able to interact with your lecturer or your course coordinator, your fellow students, and we make use of remote labs and simulations in terms of delivering our programs. And Bruce and Kerry will be covering most of that information. And on that note, I will then hand things over to Bruce. Thanks very much.
Welcome everybody. We have an agenda here up on the screen. I hope everyone can see it. We can talk about what's involved in the course, what the program structure is about, what our learning outcomes are, how we deliver the material, what sort of entry requirements there are for this course, how it's accredited, how you pay for it, very important, and what you may get as a result in terms of possibilities for job outcomes. Also talk about how much time you might need to spend on this course and what sort of support you can expect to get from EIT. So this is a summary of me, and before I talk about myself, Kerry and I'd like to know some information about you guys. Where are you from? What are you doing now? Why are you interested in this course? So maybe to help us, you could pop something into the chat box and give us some information that that Barry will be able to convey to us. So just take a couple of seconds and maybe pop something in the chat box. Tell us where you're from, what you're doing now, and why you're interested in the course. While you're doing that, I shall tell you a little bit about me. I'm an electrical engineer in electronics, particularly from the University of New South Wales in Sydney, and I got a master's degree in clinical measurements a little later on from the University of Technology in Sydney. I've had a career spanning around 50 years, starting as a technician and working up to an engineering qualification. I'm a fellow of the Institution of Engineers in Australia and a chartered professional engineer. I'm also registered on the National Engineering Register in Australia. I've held several positions in societies and learned institutions, including the Society for Medical and Biological Engineering, where I'm currently the secretary, the board of the College of Biomedical Engineers Australia, and currently the deputy chair of the National Committee for Clinical Engineering. I also convene a conference in New South Wales every March called the annual SMBE conference. And if you're ever in Australia and in New South Wales and it's March, it's a must to come along and see. I've also spent a lot of time working in developing countries, particularly in the Pacific Islands, Papua New Guinea, and in Timor-Leste. So now I'll pass over to Kerry, and she will tell you a little bit about herself.
Okay, well, there you go. There's my photo. Bruce says that my photo is, or my live camera is not up on screen. So just in case, that's me. So I did not actually write this introduction about myself, but I do love anatomy and physiology. I'm your anatomy and physiology instructor. And I hope my presentation style really shows my interest in anatomy and physiology. I'm not a biomedical engineer by background, nor am I a biomedical engineering technician. But as a clinician, I get the distinct advantage of knowing how, as an end user, the appreciation for the work of the biomedical engineering department as they are able to keep our important medical devices and equipment well maintained, calibrated, repaired, all those things that are so very important to me. Oh, that is much better. Gosh, that was we didn't realize that Bruce's mic was still on. That was very echoey in my ear, so I apologize. I was a little banging around in my head there. So I feel like we are a team. So the clinicians, the biomeds together, we are helping to take care of our patients. I've been working with Bruce, as you may or may have figured out. Bruce and I are married, and I have been working with Bruce for nearly 10 years in biomedical engineering. So although my background is as a clinician, I really do have a good understanding of biomedical engineering as well. So hopefully that's a really good sort of blend for everybody. You get the clinical side as well as the biomedical engineering side. I think that makes for a good blend. Okay, so what is biomedical engineering? Well, this is one definition that we use, and that's because Bruce and I both like this one. Biomedical engineering is the application of engineering principles and design concepts to medicine and biology for healthcare purposes, and that is monitoring, diagnosis, and treatment, or in other words, applying principles of physical sciences to the life sciences. So that, we think that's a good overall definition.
Okay, so let's have a look at an overview of the biomedical engineering sector. It's a very wide field. It embraces things like clinical engineering, rehabilitation engineering, and assistive technology. We've said that twice because we like it so much. Also biomechanics, biomaterials and tissue engineering, biomechanics and computational work, biomedical images and signal processing, biosensors, medical devices and instrumentation, which is where I know most of my knowledge is, biomedical robots and surgical technology, neuroengineering, design and manufacture of medical devices, medical imaging, radiology, nuclear medicine, ultrasound, and so on. Tissue engineering, we got that again, we like it so much. And bioengineering. Bioengineering is a funny one. We wonder sometimes what that means, but it sort of talks about biological systems, tissue and genetic engineering, chemical production, fermentation, etc., and wastewater treatment. So there's a lot of things in there that you could get your head around. So let's have a look at what the clinical engineering sector involves. Clinical engineering is the type of biomedical engineering that we typically do in hospitals and healthcare facilities. And it can involve things like adverse events or incident investigations. It can look at things like asset management, certification of products, design and documentation, education and training, installation, manufacture and supply. That's quite a lot of things, but it also runs to operation and maintenance of medical equipment, quality assurance, research and development at times, risk management, and that's becoming more and more and more important these days, and testing and evaluating products before we actually buy them, and then subscribing to regulatory requirements for the users. So there's quite a lot there that clinical engineering encompasses. If we look at the branches of biomedical engineering, just a few of them. We said a whole lot more before, but we just look at a few of them. If we look at clinical engineering, we know that that's mostly hospital based. It's basically these days repair and maintenance, tendering for new equipment, purchasing that new equipment, commissioning it when it arrives, so getting it all set up, providing the training, and then moving into the maintenance phase of it, finally into the disposal when it's reached the end of its life. Rehabilitation engineering is often conducted in a specialized unit within the health system. So a biomedical engineering service may have a assistive technology rehabilitation engineering service as part of their remit, or it may be a specialized unit that stands alone from a hospital, and they'll be doing things like assistive technology, and we talk a lot about assistive technology in module 17 in the advanced diploma, but also customized seating for people in wheelchairs and one-off designs of equipment to help people who are disabled with their daily lives. Biomedical images and signal processing, you might be looking there for work within a medical imaging company. So there's some big medical imaging companies, Philips, Siemens, GE, Canon, Shimadzu, around the world, more than those, of course, and finding employment there. In terms of medical devices and instrumentation, We will perhaps be thinking about, again, hospital-based, be doing repair and maintenance, or working for an equipment manufacturer or a vendor, a supplier of medical equipment, maybe doing field service, I should say, of product support, maybe a little bit of design. And then in biomedical robotics, and we talk about this a lot in module 18, the last module in the course, often hospital-based in specialized units, providing product support for these robotic systems. So there's ample places where you can ply your trade, as it were.
Okay. Well, thank you for those who have added to the chat. It looks like we have sort of just one or two folks that have been able to get to the chat box and tell us a little bit about your background, where you're at, and what you're currently working in, and what's your interest in biomedical engineering. So if somebody hasn't added there that they would like to, we sure would love to hear more about you. We do all the talking usually when we're instructing, and we do the talking now, and we love to hear it from you guys when you're able, or when you want to add to the conversation. So please feel free to put in the chat box a little bit more about yourself. All right, so this description of what a biomedical engineering technician comes from our friends in the Canadian Medical and Biological Engineering Society. And when I say friends, I do mean friends in that the people from the Canadian group, the society, have been really helpful for Bruce and I in our most recent work with New South Wales Health. And they're very generous, they're very knowledgeable, and they have a great society. And Bruce will give you some more about some societies and learned organizations around the globe, but they're definitely a good one to look at. But they say that for biomedical engineering technicians, they work largely in healthcare facilities, providing comprehensive service and support of medical devices and equipment. A lot of the activities include inspection, installation, repair, and preventive maintenance of medical devices and complex medical systems. And that is, again, becoming more and more true as time goes by, those complex medical systems. They also provide advice and training on the safe and effective use of medical devices and systems. And again, as a clinician, I can attest to the fact that BMETs, the biomedical engineering technicians, do train us clinicians on medical devices and systems. So we look to our colleagues in biomedical engineering for help and support with the devices that a lot of times you know better than we. We know how to apply the information gathered from the device, but you generally have a better handle on the device itself. So we're very grateful to take your advice, recommendations, and training. So biomedical engineering technicians, BMETs, contribute to improved healthcare outcomes by inspecting, repairing, calibrating, sometimes designing medical equipment that becomes more advanced and complex all the time. We talk a bit about this in modules 17 and 18 when we look at things that are sort of emerging and cutting edge. We look at devices that are being developed in the biomedical engineering field, or that BME is part of their development. BMETs keep biomedical equipment in working order by performing tests, by following preventive maintenance guides, by repairing, troubleshooting when something breaks down, working with service contracts, ordering services if necessary, and maintaining a good inventory of spare parts and other replacements. Biomedical engineering technicians use their knowledge to prevent electrical and mechanical faults that could lead clinicians to the wrong diagnosis. So wrong diagnosis leads to the wrong treatment plan that either delays appropriate treatment or may harm the patient outright. So really helpful to have the BMETs participating in the care of patients by using their knowledge to prevent electrical and mechanical faults of our important medical devices. And BMET set up preventative maintenance programs to keep life-saving equipment running. So pretty important tasks in the hands of the BMETs.
We seem to have missed a slide. So let's talk then about what biomedical engineers do. Biomedical engineers typically do the following. They design equipment and devices. They could be doing artificial internal organs or replacements for body parts. They could be prostheses or orthoses or machines for diagnosing medical problems. That's a pretty simple statement, which covers a whole lot of complex things. But often also installing, maintaining, providing technical support for biomedical equipment. And you can see in this little graphic over on the side that there are lots of different things that happen in the biomedical engineer's workplace. So once you get into this field, this biomedical engineering or clinical engineering or rehabilitation engineering field, you'll find that there are lots of international organizations that can cater for your what's called learned society function. And one of the most important is the International Federation for Medical and Biological Engineering, the IFMBE. And the IFMBE has a clinical engineering division that looks after the type of people that work in hospitals as either clinical engineers, biomedical engineers, or biomedical engineering technicians, BMETs. The Institution of Electrical and Electronics Engineers, the IEEE, the biggest engineering society in the world, has a engineering in medicine and biology society called the EMBS, which is very active across the world. There's an American College of Clinical Engineers, the ACCE. There's the Canadian Society that Kerry mentioned before, and there's the AAMI group, which is more a confederation of manufacturers and suppliers. But in the countries that you come from, there will be learned societies, institutions that are representing the interests of biomedical engineers, biomedical engineering technicians, and you can find those. I reference those in our in one of the modules that we teach. In Australia, we have the Engineers Australia. It's about 110,000 member organisation. The Engineers Australia has several colleges: electrical, electronics, mechanical, civil, environmental, and so on, for all the engineering disciplines. But what we're interested in is the Biomedical Engineering College, and that has two committees: the National Committee for Clinical Engineering and the National Committee for Rehabilitation Engineering. And the college is very active and most active through those committees. We also have societies for medical and biological engineering in some of the states of Australia. There's the SMBE New South Wales, there's the SMBE Victoria, which looks after Tasmania as well, and the SMBE South Australia, which looks after the Northern Territory as well. We don't have an SMBE for Queensland or Western Australia. And there's lots of reasons for that. And you can see their logos there on the screen. If I change the slide, you'll be able to see those on the screen. So the college, the national committees, and the societies for medical and biological engineering, and their logos, which you'll come to recognise. There are also plenty of resources, apart from the resources that EIT provides for your learning. There are many resources like the 24/7 magazine, the Biomedical Engineering Online Forum, the Australia's Biomedical Engineering College page, the Australian BME website, the SMBE New South Wales website, and there's plenty more of those that you can hook onto and see what's happening in the industry. So let's
Pardon me, and give it a little cough there. So let's look a little bit more at the EIT's Advanced Diploma of Biomedical Engineering here. So the course overview, it is an advanced diploma. We attempt our very best to have a very practical focus. Students generally emerge being able to demonstrate a better understanding of the technical and theoretical knowledge of biomedical engineering and in the subject matter related to biomedical engineering. I would say the vast majority is about clinical engineering, so about work in large healthcare facilities, as well as we do cover some of the rehabilitation engineering, assistive technology, and emerging technology. And so we do have topics that are involved in the broader BME, but a large part of it is in clinical engineering. The course benefits, the skills in the latest biomedical engineering technology, certainly we try and put into our last two modules of the course. A lot of cutting edge medical devices and technology. In module 17, we look at innovations in assistive technology and rehabilitation. And in module 18, we look at emerging technology more related to sort of in-home and in-hospital patient care. So we are keeping up to date with sort of the latest technology that's out there. Also embedding into the topics as things like cybersecurity, as ICT, so those types of issues and relationships within the hospital, whether it's working with networking of devices, that those topics continue to sort of grow in prominence in the course as well as they become more important to your work in the hospital. Practical guidance from experts in the field. Well, Bruce certainly will provide his students with real world scenarios and practical solutions that he's gathered over decades in the field. And our other expert instructors will provide their own sort of stories and solutions from their backgrounds and experiences as well as you'll get from me a little bit about the clinical side of how the medical devices have impacted the lives of clinicians and patients. Global networking contacts in the industry, well, certainly EIT is a real global effort. Your instructors and classmates will most likely come from many different countries and backgrounds. It's one of Bruce and my favorite thing about instructing for EIT is really just how global it is. Our students come from around the world. Our colleagues come from all sorts of interesting backgrounds and interesting areas of the world. And I think together we make it a very sort of fun and interactive classroom experience for everyone. Improved career prospects and income. Well, many students use this advanced diploma of biomedical engineering to either change careers. So we haven't heard where a lot of you are currently working, but a lot of people use this advanced diploma as a way to sort of move between different professions or careers. Or many people are already working in the field. Maybe they are BMETs already, and they are using this to sort of further their career prospects or maybe even advance their income. And other students use this advanced diploma as sort of a stepping stone into additional education, so into higher degrees. So lots of different sort of benefits that you get out of it. And you also receive a world-class advanced diploma of biomedical engineering from EIT. There is a student loan program for this course for eligible Australian students. So without knowing where most of you come from, I don't know if that applies to you or not. Okay, so this is a recap a bit about the previous information. So when I was reading through this slide, I was really impressed upon by the fact that we have a tremendous amount of experience in the biomedical engineering field through your instructors and through your course presenters and course assessors. The practical program avoids too much emphasis on theory. The difficulty is as an online education program, of course, we don't have a huge opportunity to work with you on a hands-on basis, but we do try and apply practical solutions and not just simply all textbook type of information. We deliver this through live and interactive webinars. So this is a synchronous type of delivery system where we are lecturing or instructing to you live. You have an opportunity to communicate with us, ask us immediate questions, ask for clarification. That's the benefit of having it being live. We use a platform that's very helpful. We are able to play videos within that platform. And it's a really nice way of delivering a tutorial. We also use remote and virtual laboratories and simulation software. So there's all sorts of opportunities to have different type of practical exams or assessments throughout your 18 modules. And we try and make it as interesting and as interactive as we possibly can.
Okay, let's look at the program structure. The programs consist of 15 modules and 3 units of competency. Wide range of aspects giving you maximum practical coverage in the field of biomedical engineering. Kerry instructs anatomy and physiology, as she said, DBE APE 610. I instruct 4 modules by myself. That's modules 13, 14, 15, and 16. They have longer numbers, and you can see them on your screen there. And we do 17 and 18 together. But that's what 7 modules out of 18. The other 11 modules are instructed by very, very competent people with very vast experience over many years. And they will bring to you a wealth of knowledge in all sorts of things like power electronics and microcontrollers and signal processing, all highly mathematical concepts that I'm glad I'm not doing. So we've got 7, and you'll see us probably more than any of the other instructors, but some of those instructors do 2 or 3 modules, and they provide a wealth of experience in those. So let's talk about the course learning outcomes. In terms of the learning outcomes that we talk about, then as engineering paraprofessionals, graduates will be able to recognize electrical and electronic concepts which apply to biomedical equipment. I don't know why we call it biomedical equipment. It's medical equipment, but that's what we call it. You'll be able to identify and assess all sorts of details regarding networking and communication parameters for medical devices, because these days pretty much every medical device within a hospital is going to be networked, and it's going to be connected to the electronic health record. And so it's becoming more and more important to understand IT, networking, and communications. And to that end, when we revised this course about 4 years ago, we put in a subject on IT, networking, cybersecurity, and all of that. You'll be developing procedures to operate and maintain biomedical equipment and instrumentation. You'll be looking at solutions with respect to biomedical technologies. You'll be looking at the data that comes from biomedical and image processing equipment and maybe doing something with that if you're lucky. That would be very interesting. Looking to differentiate and justify appropriate biomedical engineering for measurement and imaging in specific aspects. So you'll be looking at sort of what is the appropriate equipment to be specifying and tendering for a particular requirement within the hospital. Planning and communicating and implementing engineering solutions related to equipment and instrumentation, managing projects. You might there might be a redevelopment of the hospital you work at, and you may be helping to manage that project in terms of the medical equipment, which is what Kerry and I do as our day jobs. You might be looking towards self-autonomy, achieving objectives within the organisation, developing professional practice in the field. You may join a society and become active in that and helping to develop professional practice. Our National Committee for Clinical Engineering is just in the process of developing competency standards for clinical engineers and biomedical engineering technicians. And of course, you could be doing that, and that is one of the things that the course learning outcomes will help you with. And communicating professionally and effectively. So
all right. Well, Bruce and I are at least in the same room, so when we are uncertain about who's delivering the next slide, we can at least glance over and double check with one another. So how do we deliver your course? So the delivery methods that we use are an online delivery, right? So we're not in a brick and mortar context. We do an online delivery. We use live and interactive tutorials. So there is generally a weekly live tutorial that's offered. It is delivered over the course of about an hour to an hour and a half, just depending upon the length of the topic. There's also pre-recordings that we anticipate or expect that our students will look at, and then we talk about those in class. So there's some pre-recordings, some pre-learnings, and then the live tutorial, of which can be a discussion about what you have learned in your pre-recordings, or a talk about what we're presenting live. We have a broad range of different lecturers, all the way from the clinicians to the biomeds to other types of engineers that are all part of this advanced diploma of biomedical engineering. You'll have a learning support officer. They're dedicated basically to supporting you through the 18 modules. Then we have technology that is been developed by EIT that will help you with remote and virtual laboratories and all sorts of interesting simulation software. I personally have not been involved with any hands-on workshops, nor am I aware of any hands-on workshops within this particular advanced diploma. Now, I could be wrong. Perhaps that's something that Barry would have more information about, but I do not know of any hands-on workshops that are part of this advanced diploma of biomedical engineering. Again, it's a synchronous delivery, meaning live. And we expect that is a better opportunity for you to sort of gain knowledge, to be able to communicate with us, to clarify things, to ask us for further information, and to offer information about your sort of experience. So it's a two-way street often when our students can bring us sort of interesting problems and creative solutions that they've been a part of.
We've just lost the slides. All right,
I'll bring it up just now. Okay, I see we were.
Slide number 27.
Yeah. 27. Yes. And do you want me to jump in here, Bruce, or?
I think if you go back one slide, Barry, I'll talk about the remote and virtual labs.
Okay. Perfect.
Okay. Thank you for that. This is new technology to us, and we're flailing, but not failing. The lab hosting platform is called ElectroMeet. It's a very interesting platform, and you can do remote and virtual labs in real time. You have to book a time, and there is some information that's given to you and stressed to you that you should book your labs early, because if you leave it till the end, then everybody else will be looking at the labs, and you'll have trouble finding a time slot. But once connected, you'll have access to a wide range of engineering software and connected hardware, and you can use this in your practical assessments throughout the course. There's two types. There's remote labs and there's virtual labs. The hands-on remote labs, where you actually control physical equipment and sensors. These are mimicking what you would find in a traditional brick-and-mortar university engineering lab. The controls are interactive. You can control, you can vary, and you can look over webcams in real time. With examples including data communication protocols, scientific instrumentation, physical experiments, control and observation of circuits and systems and machinery, and even robotic automation. And you can see the immediate results of these experimentations. So that's the remote labs. There's also the virtual labs, where ElectroMeet has simulation software for a multitude of engineering applications. And we use a couple of those in this course. We use an ECG simulator, and we use a ventilator simulator. And so we make good use of that. You can do modeling and analysis, you can do programming, you can design power networks and construct models and design and draft systems, you can do project management, industrial process control, and you can operate a virtual plant. So it's very powerful. These virtual and remote labs are hosted primarily in Perth in Western Australia, but there are also some additional labs in Johannesburg and in London even. And you need, as I said, to pre-book so you get access to the required labs. Now I'm going to hand back to Barry.
Yeah, thanks very much, Bruce and Kerry, for your such an insightful information. I like the previous guy's comment that no knowledge is a waste, indeed. So yeah, we're just going to touch base on entry criteria into this program. So you are required to have at least year 12 or certificate 3 or trade qualification in the or equivalent qualification, and then you need at least 2 years of work experience in the engineering field. And also, if for instance you haven't done your qualifications in English, you might be required to write English proficiency test. As you can see, the score that is required, 5.5 with less than with no less than 5.0 across all the bands. And then with fees, so we do have option of payments in terms of that you can pay the cost on a monthly basis, but we also have VET student loan, of which is only Australian students are eligible for this, as it's covered by Australian government. So obviously, once you have been approved for a VAT loan, then the broad amount will be incurred as a debt for repayable to the Commonwealth government. And in terms of accreditation, so this course is officially accredited with TEC, Training Accreditation Council, and obviously EIT has been approved by ASQA to deliver these programs across Australian states. So obviously EIT deliver these programs also across the globe to our students from different parts of the globe. So in most cases with accreditation, we also encourage students to find out more information with regarding the country-specific accreditation and professional recognition. And then in terms of AQF level, this qualification is sitting at level 6. Some of the potential job opportunities, once you've completed the qualification, we're looking at field service technician, medical equipment service technician, engineering technician, instrumentation, medical sales, engineering associate, and also as a maintenance technician. And we get a lot of questions, especially with softwares, in terms of what softwares does EIT use in programs. So in this advanced diploma, you'll see we have a whole number of softwares that we use. In fact, what I did is I just put a link in the chat box. This link will also just take you to this course. Then you're able to read more in terms of the benefits, course overview, and you can read more on these softwares that we use. Right. All right. In terms of obviously time commitment and the duration of the program, we're looking at 18 months course duration for this course, and you're expected to spend at least 10 to 15 hours per week. This obviously include attending live interactive webinars, obviously completing some of the assessments. And with live webinars, obviously, because we understand that most of our students, people are working in the engineering field, and we sort of like try to also to make it flexible to work and study at the same time. And so let's say you are not able to attend a live session, so we leave a recording for you, so you can always go back and sort of like listen to the recording. However, you need to sort of like provide some sort of like a summary as to what was the webinar all about, so that your course coordinator will be able to have some sense of you do understand what was the session all about. Right. And then I must say EIT is really huge in terms of supporting students. Students are really big deal of this institution, and we really ensure that we give them all the support they need. Again, studying online can be, a bit intense, and you need people to support you as you move on. So we have what we call learning support officers. So these are not engineers, but these are sort of like people who are there if in terms of just to make sure that you meet the deadlines. You provide whatever it's needed. If you have like some issues with balancing work and study, and maybe you sort of like want to defer other units or something like that, they are able to step in to assist you. And then you will get also support from our academics. Obviously, this will cover most of units that you do, any technical questions that you might have, and then you have your academic team to assist you. And also we have tech support in terms of maybe your portal is not working, you are having an issue in terms of accessing your remote labs or simulations, things like that. You can reach out to our tech support, and then they are able to support you to ensure that everything is running smoothly on your end. And we just thought we could share some sort of like a feedback from some of students. Then you can see Ain Goja from United Arab Emirates. One of the best online courses that I completed. It's very relevant to my current work and will definitely elevate my rank. And as I've mentioned, that we offer courses that are industry aligned. And El Palatino from Australia, my background in electronics engineering, so I enjoyed all this medical module, especially anatomy and physiology, because it's all new. It's all new to me. And then lastly, A. Kumar from Australia. The course has tried to bring a broad perspective of biomedical engineering into one platter, which is commendable. Also, course coordinator was very supportive throughout the course. She did an excellent job. Additionally, all the instructors did a splendid job. So that goes back to the support that you get from our lecturers, learning support officer, and as well as the rest of my colleagues at EIT. And yes, some of upcoming webinars, we have exploring artificial intelligence in mechanical engineering. It's coming next week. We're having unlocking the power of edge computing, real-time decision making, the device level, which is also coming on the 18th. So if you're interested in these sessions, you can always just go on our website and register. So I'm now going to just open the floor for any questions that you might have for me, Bruce, as well as Kerry. Any technical question that you might have, Kerry and Bruce, they are here to assist you. I'm just checking if there's anything here. Q&A. Hey, Bruce, I just got this question as well. I just put it in the chat. Yeah, I think I can do the.
Consulting.
In fact,
Interesting.
the PhD one, I'll just share a link for our doctorate so you can read more. Thanks for answering that one, Kerry. Please, I'm interested in the program. Please, any international students and being supported in terms of fees. So we do have partial scholarships programs that I would say you can look into. And once again, you are able to pay on a monthly basis on this program. I'll just put in the link now, and then you can read more. Thanks, Bruce. Any questions, anyone? All right. I guess on that note, Kerry and Bruce, I'm not sure if maybe you have any last comments that you want to share.
I'll just share that I've been very impressed. Bruce and I have been working with EIT since 2016. And I think one of the things that just really keeps us involved with EIT, keeps us coming back again and again, year after year, is really how genuinely people that work with EIT want the best for their students. So your LSOs, your college director, each of your instructors, everyone from the top to all the way through the ladder of EIT's employees all really want the students to succeed and will go out of their way to make sure that the experience is the best possible. And I think that that type of student support is really what attracts me as an instructor, to see that not only that, you know, that I'm passionate about what I teach, but that everybody that works with the EIT is equally as passionate about making sure that the students are considered first and that their experience is really the best that we can possibly deliver. So that's what keeps me with EIT as an instructor.
Thanks, Kerry.
What she said, I totally agree. She stole it from me. But no, we both say the same thing all the time. But that's what we like.
Okay. Thanks very much, and Kerry and Bruce, for delivering this session. And I just want to say thanks to our audience. Yeah, so if you're looking for more of these sessions, just go on our website and register, and have a great day further. And Bruce and Kerry, all the best. Thanks very much.
Thank you, everybody.